So today we are going to see something about circle generation. So here we will start by understanding what a circle is, and then we will see how can we generate a circle on this raster scan system. Okay. So here this is a circle. What is a circle? Actually you can define a circle as a set of points which are on the circumference. These points are equidistant from the center. Okay, suppose the center is xc, yc. Okay, so all the points on the circumference, they are equidistant. The equal distance is r. Okay, the radius. Equally they are distant from the center. So this is the very important thing using which we will try to plot the circle. So all those points which are equally distant from or which are at the distance r from the center, they will be plotted, right. So suppose this is xc, yc, and let me consider is x, y. So what is the I should say relationship between these r and these two endpoints? This can be expressed as Pythagoras theorem, like x minus xc. What is this? This part, and a square of this thing plus this part. This is y minus yc, square. What is this equal to? This will be the hypotenuse of this particular triangle, right? This is r square. So using this equation, if at all we are aware of the center points, this is our center point xc, yc, and we are also aware of the radius, then definitely using one of the value, giving one of the value of x, we can easily find the value of y. How? You can find it like y is equal to y center plus or minus under root r square minus xc minus x square. Okay, how this has happened? Using by simplifying this equation, right? So now you can keep a value of x. Okay, you are aware that r is given, xc and yc is given, and if you use some value of x, you can easily find the value of y. Now the question is which value of x should be used, right? So you understand this is the center point xc. xc minus r is this point, and xc plus r is this point, right? So from xc minus r to xc plus r, between these positions, if you are able to increment the x by constant unit, maybe 1 unit, and for each pixel you will keep on finding the value of y, then you can easily find the circle. However, using this method of finding y for each pixel is considerably more computation. I should say more computation is needed. Okay. So here not only more computation, one more thing you will see, where these pixels are which will be plotted are not equidistant. Okay, means at this position and this position, when you are finding the next pixel, these two will be far away, right? So let me show how it will look like. So it will look something like this, okay, where here you can see when the pixels were near, then this was possible. Let me zoom it a little. See, so when the pixels are near for one pixel and for the next pixel, it will find the value of y, which is here. However, here in this case you can see for the next pixel they are just together, so it looks something which is continuous. However, here it doesn't seems continuous also here. So these things you can understand because of the slope, right? Here you can see it has to go in this direction, right? So if we are going in this direction, what should we do? We will have to consider all those pixels to be plotted. So for this there is one option that for now we have considered the x axis and found the values, and then we can start doing the same with y axis, ranging the y value from suppose yc minus okay, here it is yc plus r, and here it would be yc minus r. So considering these points, between these if we will find again the value of for each y, we will increment the y with 1 unit and try to find the value of x, then we can easily plot the circle, and in that case when we will do something like this, we will find the value of these points which will look continuous, and these points may not be continuous. However, we have got these points from the by using the x value, right? So in that way, if we will do for x as well as for y, then we can make it continuous. Now here you understand that by doing this we are making it more computing kind of thing, more computation is required for this, okay. So in that case we are not going to use this equation for finding this. However, we will understand that this equation is important. So we will come to this equation again when we will think something else, some other algorithm. However, one more alternative is to go with polar coordinates, okay. Polar coordinates means r and theta, okay. So now what is r and what is theta? R is the radius and theta is the angle at which in a circle, suppose this is r, so this is theta, okay. So now here if you want to find the value of x and y, then the x can be written as x center plus r cos theta, and y can be written as y center plus r sin theta. So using these equation also you can find the values of these things. Now here you have to consider what value of theta should be taken. This theta, if it is very small, then much computation will be needed, and if it is large enough, then some points may be left out, right. So, in case if some points are left out, what is suggested is we can draw a straight line between them to make up the left out points in the circle. But still, one more thing that is given, that the theta can be taken as 1 by r. That is also helpful many a times. But still, what thing is how we are going to deal with all these things. One thing here is definitely here we are reducing the computation than that particular under root and those square root calculations. But still there is a required amount of computation. Okay. Now, while calculation, one more thing that we can understand here is the portion are symmetric. Symmetric means the arc in this quadrant is similar to the arc in this quadrant. Okay. So, once we have calculated these, we can easily change the value of positive and negative things. Okay. Like here the values will change and it will be just symmetric to this particular position. And once we have calculated these things, the two quadrants, first and second quadrant, we can easily find the values of the this circumference pixels using the values of the symmetric values from here. Okay. But still, one thing that I can mention here, that earlier while we were thinking about Bresnam's line drawing algorithm, it was just trying to find the next pixel. Okay. Next pixel which is nearer to the straight line, right, which is the next pixel which is nearer to the straight line, whether I should keep the value of y as it is or I should increase it. Okay. So, that is what we were doing in Bresnam's line drawing algorithm. However, now what we are doing, we are either using that particular formula of a square root, or we are using this complexity related to trigonometry. Okay. So, both of these, either we are going for trigonometric calculations or other square root calculations, we are involving these kind of multiplications and increased complexity. However, we know one thing, that in Bresnam's line algorithm such kind of thing was possible. So, we have to search for a method where we could avoid these kind of calculations and still are able to find this particular pixels of the circle. For this, in the next video we will see something about midpoint circle algorithm. Midpoint circle algorithm, which will be similar to Bresnam's algorithm you have seen, where you will try to find out the next pixel which is nearer to the circle circumference. Okay. So, midpoint circle algorithm. Okay. For now, we will have to stop here. Thank you.